AI is reshaping industries. But behind every AI breakthrough, there's a massive infrastructure that powers it. And that infrastructure sometimes can be challenging. So how do you handle the relentless demands of the AI workloads? From training massive models to serving real-time inferences. Software-defined data centers can be called as a solution to these kind of problems. In the next few minutes, we'll look into how software-defined data center or SDDCs play a vital role in enabling whether you should choose a hyper-converged infrastructure or a converged infrastructure, which is HCI and CI respectively, for your AI workloads, and how to build SDDC or software-defined data center on a budget. Open source versus closed source, and role of Docker and the best practices for building an AI solution on top of your SDDC. Now, we won't do a deep dive. This is a high-level overview for your understanding on how easy it is to build your own SDDC and then have your AI workloads hosted on a budget. Now, what is a software-defined data center? Now, we all know about the traditional data centers, right? Racks, servers, storage, network, whatever. So software-defined data center virtualizes all the core components. Compute, storage, networking, and security. So these resources are controlled through software rather than the physical hardware. Now, this allows for flexibility and also allows SDDCs to scale seamlessly to meet the dynamic demands of AI workloads and do so without the typical latency and the cost overhead of the traditional hardware or traditional data centers, basically. So, in a sense, SDDC transforms physical infrastructure into a highly automated, agile system where the resources can be allocated dynamically and as needed. Let's look into differences of HCI versus CI, or hyper-converged infrastructure and the converged infrastructure, and which is best for AI workloads. So when it comes to running AI workloads in an SDDC, two major infrastructure designs emerge, CI or converged infrastructure, or HCI, hyperconverged infrastructure. Converged infrastructure, or CI, integrates compute, storage, and networking into a single optimized system, but retains the separation between these elements. You can manage each independently, which offers a modular approach. CI typically suits the enterprises with large-scale, consistent workloads and is favored in environments where the storage and compute scaling requirements vary independently. So what are the best AI workloads that we can run on CI? So it's basically best suited for inference workloads that demand high performance and low latency, but may not require frequent reconfigurations during as it happens in the AI trainings. On the other hand, when we look at hyperconverged infrastructure, or HCI, now HCI has compute, storage, networking, security into a single virtualized system. So it's sold together, not like the CI, which is independently controlled, and it provides a unified platform. This reduces the complexity and allows for greater flexibility, making it particularly well suited for dynamic workloads like model training, for example, when we talk about AI. Now, HCI is also easier to manage and automate compared to the CI, making it a popular choice for organizations with fast-changing resource demands like AI model training, where scaling and compute and storage are the main pillars, and they have to work in parallel. That's kind of like a requirement. Now, which workloads of AI is HCI best suited for? Now, HCI excels in model training. So you're bringing in your data or training anything, because of the processing, compute, scalability, storage, everything. So HCI gives you the best component when you think about like fast moving and training of the multiple models and whatnot. So, and also to consider the ease of automation and flexibility and scaling the resources makes HCI very powerful when it comes to AI training. Which model is better for AI? So for AI workloads, particularly working with large models, HCI generally comes out on top. The flexibility it provides makes it easier to accommodate the intense demand of AI training, where massive amounts of data needs to be processed and models needs to be recalibrated every now and then, basically on the fly. CI may work better if your focus is on AI inference and the workloads that do not require a dynamic infrastructure, frequent changes, but require higher performance, lower latencies and whatnot with the predictable outcomes. So that's where CI scales. Docker, everybody talks about it. Now let's look at, should we use it or not use it with the AI workload? Now, containers, particularly Docker, is extremely popular due to ease of use, and they've become integral part of modern AI deployments, and even not just modern AI, everything. So whenever you're deploying a software, it's there. And the question is, should you use Docker in your SDDC setup? And why? So Docker containers ensure that your AI applications run consistently across different environments. Now, one of the things that everybody says in the tech world is this application doesn't run on my PC. Docker takes that excuse away. Then there's scalability. Now, containers can scale horizontally, allowing you to handle spikes in AI workloads, especially if you're running agents or your apps on that leverages AI, and you can manage the demand efficiently. Another aspect is isolation. Now, each AI workload can run isolated in its own container, making it easier to manage the dependencies and prevent the conflicts. There are tons of tutorials on YouTube if you want to understand more about what Docker does. And Docker is quite popular when it comes to microservices. So if you're building the high-performing apps which can potentially have a lot of users, you can actually containerize that, different components of it, Docker network, make them talk to each other, maybe like do some automation. Now, what are the best practices for using Docker in AI? We all know Kubernetes. So Kubernetes is used to orchestrate Docker containers, especially when it comes to AI. Kubernetes will handle scaling, load balancing, recovery, prevent failure of your AI containers automatically. If you're running on heavy workloads, use GPU-accelerated Docker containers for your AI workloads, which involves deep learning or similar. It can be anything with the GPU-intensive task, maybe image generation, something like that. Frameworks like NVIDIA Docker allow you to take advantage of GPU resources seamlessly when the application is running on the Docker container. Always use version-controlled Docker images, because if you are having an application that runs perfect, that's actually built a couple of years back, and there was Python version 3.1.2, and then you downloaded the image, which is latest, and then you try to run your application, it doesn't work due to compatibility. If you go to Docker Hub, they've got all sorts of images, and you can select what image you are pulling. So if you're using command prompt to pull a Docker image, let's say you type Docker pull and you say Python, that will bring down the latest image of Python. But if you say Docker pull Python 3.1. something or 3.12, whatever is going on or whatever you built on your application on, that's most important. Otherwise, Docker can create a little bit of trouble when running your application because it might not perform as you desire it to perform. Another thing is if you use the application, the version control images, it helps you ensure the traceability and repeatability of your AI experiments when not to use Docker. So if your workloads require very low latency, such as real-time inference systems, the overhead introduced by the containers can affect it a little bit. I mean, not too much, but still, it does affect if it's real-time inference you're running on very large workloads, data sets basically. So in those cases, running that kind of workload on a virtual machine is more reliable because virtual machines can guarantee better performance. What you should look when you're actually creating a software-defined data center with the vision to have your AI applications running off it. Maybe you're serving internally to the users. Maybe you're serving applications to external users. Let's take a high-level look. First off, leverage the GPU. So AI workloads often require heavy computational power, especially for training. Make sure the SDDC includes support for the GPU-based computing. A lot of SDDC providers provided by default. Open source tools like Kubernetes with NVIDIA GPU operator can help manage GPU resources very efficiently. Automate everything. AI workloads fluctuate drastically. Use tools like Ansible, Terraform, Kubernetes to automate scaling and resource allocation. Automation also reduces the manual intervention and optimizes performance and cost at the same time. Monitor performance. Use monitoring tools like Prometheus for metrics, Grafana for virtualization to keep track of your SDDC's performance in real time. You do realize all the tools we are talking about right now, they're all open source, completely free to use. Optimizing data storage. Now, AI training requires fast access to large data sets. Distributed storage systems like Ceph, CEPH, I'll put the link in description, or Gluster file system to ensure scalable and reliable storage solutions. Again, they all support software-defined data center approach as well. They can be the best bet. Now to the most exciting part. Let's see what you need to build your software-defined data center on a budget. First, let's take a look at the hardware and what it can cost you roughly. Building a software-defined data center for AI on a budget is quite difficult. So, but it's entirely doable. And what I've done is I've put together some figures which I collected from the internet, some requirements. By no means this information is exhaustive or I'm guaranteeing anything. It's just the research that I did and I thought of sharing with you. So when you're building your software-defined data center, you need to look at the right mix of the hardware and the software. So the key to success lies in balancing the performance, scalability, and cost as well, without compromising your AI workload's quality and the ability to run efficiently. So what hardware do you need for an AI-capable software-defined data center on a budget, of course? An AI-ready SDDC requires compute, storage, networking, and power-efficient hardware. But how do you prioritize these components on a budget? So let's break it down. Compute resources, GPU and the CPU. So AI workloads, especially training large language models like those using deep learning, need powerful compute resources. A basic CPU only setup would be inadequate, and if you're planning to train massive data sets, so definitely you need GPU and GPU acceleration, which is crucial. For CPUs, standard AI inference workloads or light training, a mix of AMD EPYC or Intel Xeon processors will do the job. Both brands offer multi-core processors with high memory bandwidth, which is crucial for handling large data sets. And when it comes to GPUs, NVIDIA GPUs are the best, of course, AMD is catching up really fast. Best performance when we talk about AI workloads, especially when it comes to deep learning. Now, depending on your budget, you can opt for NVIDIA A100s or V100s. The most powerful GPUs for the AI workloads are best suited for large-scale training is A100s and V100s. But NVIDIA RTX 3090, I mean, you get them in the laptops as well, so you can use them as well, but not really recommended when you're talking about training a lot of data, like a chatbot serving, I don't know, 200-300 customers concurrently. So for a more budget-conscious option, consumer-grade GPU, which is 3090, they, like I said, they can give you the performance if you're serving about 10 users or 15, maybe 20. What can be the estimated budget for a compute? So a basic setup would set you back anywhere between $2,000 to $5,000, which would include high-end CPUs, 1 to 2 consumer-grade GPUs, which can be 3090s, 4090s. Recently, NVIDIA announced the 5090, 5080 series as well. For the mid-range, when we talk about the compute itself, it's going to set you back about 10 to 30,000 plus minus, depending on how you do it, which can potentially include 4 high-end CPUs, 2 to 4 enterprise GPUs. That's consumer grade we're talking about. For the enterprise setup, again, talking about compute, so we are looking at 50,000 or more, which would be A100s or V100 GPUs. Now, when we look at the storage solutions, AI workloads often deal with massive data sets. I mean, we have to have it scalable and high performance storage is needed, right? So you'll need a combination of the SSDs for fast data access, NVMEs, and large capacity HDDs, if possible, for bulk storage, maybe your repository or your data files and whatnot when you're doing model training. With SSD or NVMe for hot data, you can store your AI models and access them more frequently than because they've got high read-write speeds and whatnot. So HDD or hard drive, regular hard drive, SATA and whatnot for cold storage. Now, for storing large data sets that aren't accessed as often, you can use SAS HDDs or SATA HDDs for cost efficiency. When we talk about the budget for this one, it comes consumer grade SSDs like Samsung 970 EVO. They're enterprise grade, and then for HDD you can go for Seagate or something similar. And to ensure again your data storage is scalable and fault tolerant, Ceph, which I mentioned before, link in description. Ceph is a software-defined storage solution, and it's open source. It provides redundancy to handle both object and block storage, and which is essential for AI workloads. Now, estimated budget when it comes to storage, the basic setup would put you back around 1,000 to 2,500 roughly when we are talking just about storage. Then if you talk about mid-range, up to 10,000, enterprise 20,000 or more, depending on your requirement and what you want to do with it. Now, when we look at the networking side of it, now networking in software-defined data center, networking is just as crucial as compute and storage. So AI workloads, especially distributed training, involve transferring massive amounts of data between the nodes, and you need high-speed networking to ensure minimal latency and smooth data flow. Now, 10 GB Ethernet network switches that can be an option. Use them to support fast movement of data between your compute nodes. For cost efficiency, use brands like Ubiquiti, or they offer decent performance. I would recommend Cisco or Juniper or some top grade if you can afford to invest, because network is kind of like the core, so I think you should try to invest a little bit more. Then when we talk about the large enterprises, we're looking at 40 gig plus. Now we're talking about 400 gigs and 800 gig models. So it just keeps increasing. Someday soon, maybe by the end of the year, we'll hear terabyte, 2 terabyte data transfer, something like that. But so having said that, when we talk about the enterprises, I mean, you can go as big as you want because, and again, there's a lot of investment that you need to do in it. And so like Cisco or NVIDIA, InfiniBand and whatnot, they are the best solutions when it comes to really building the core of it. Cost for the networking basic setup up to 2,500, and that's the max. This is the upper limit. For the medium size, we're talking about up to $10,000, and for the enterprises, it can be anything. I mean, it depends on how big you want it. So starting with $25,000, going all the way up to 200, 300, whatever your workload looks like. Now, there's another aspect which is power and cooling when we talk about the data center, and we are kind of building it on a budget, right? So we're just looking at the differences so you understand what not to do, right? So when it comes to AI workloads, again, power is most important because an uninterrupted power while you're training the models. I mean, they are resource heavy. We're talking about AI workloads, they're quite resource heavy with GPUs consuming a ton of power. Now, you need robust cooling to avoid performance throttling. You'll need robust cooling to avoid performance throttling. And so you need good power supply and good cooling source. Now, this can set you back for basic start about $2,000. Mid-range, you're looking at about $8,000 to $10,000, and for enterprise setup, it can go above $10,000. Again, depending on how big it is. Now, so this is the hardware side. Now, let's look at some of the software that you can use. Now, this list has got open source and closed source both. Building SDDC for AI on a budget, it sounds expensive when it comes to the software part, but it actually is not. So if you make smart choices, and especially when you look at the open source tools that are available now, and if you know a little bit of coding, take help from a friend, you can actually build something quite decent which can scale, can support up to 3, 5, 10,000 users simultaneously, depending on how you design it. But there are open source tools available to actually build this. Now, let's look at some of the open source. So hardware investment, you have to make that. So about $10,000 plus minus. That's what you're looking at for a basics for setup that can build, that can support the software-defined data center that will run AI application. Now, when we look at the open source software, so let's look at compute first. So what I like is Promox. Again, link in description. Promox is an excellent open source tool for virtualization platform that can handle AI workloads efficiently. It supports both containers and virtual machines. KVM or kernel-based virtual machines combined with tools like OpenStack can give you a fully flexible compute layer at a minimal cost. Now, when we talk about storage, Ceph is a highly scalable open source storage solution used in AI environments for its ability to provide both block and object storage. Next is networking. The software that I like is Open vSwitch. It's a great choice for virtualized networking within your SDDC environment. So it offers high flexibility and can integrate well with the tools like OpenStack, Neutron, and others. Now, if you look at automation, because that's the core component of software-defined data centers. So you can go with Ansible, Terraform. You can actually mix them, use their strengths and whatnot, and they can automate the deployment that is scaling off of your infrastructure, handling critical dynamic AI workloads. So with open source tools, the beauty of that is you don't have to spend a dime in the software. You just need to arrange for the hardware. You can start with a decently powered laptop if you've got something with a 64 gigs of memory, i9 processor, probably a 12 gig virtual RAM on the GPU, and a decent sized motherboard, and about like a couple of terabytes of SSD in your laptop. And I'm just defining popular gaming laptops like the Lenovo Legion or Dell Alienware or HPE Victus and others. They are actually giving these kind of configurations. So if you have got one of that sitting around in your house, you might want to start downloading the tools and start start building your software-defined data center. You can even use VirtualBox, which is a virtualization platform by Oracle, and you can actually start building the whole thing there. Or use OpenShift. If you want a little bit on the enterprise version, talk to Red Hat and get their OpenShift, which is great. Or maybe and use Ansible from Red Hat for automation, or that's available for downloads as well. And I think there's a Git repository as well if you want to fork out something and try to build on it. I haven't tried, so don't know about that much, but I think there is something. Well, so having said that, you're able to easily build your software-defined data center if you've got decent hardware lying around the house. Otherwise, you can just purchase some basic hardware, basic gaming hardware, not basic, a little bit better. But yeah, a regular gaming hardware, you should be able to get your software-defined data center running there, and you're able to actually start working and building your AI workloads on top of it. Now, if you look at closed source, no points for guessing. But these platforms are pretty straightforward. So Google Cloud, Azure, AWS, VMware, vSphere, Nutanix, all the known closed source companies and virtualization providers. So that's that. So the rise of AI is actually pushing infrastructure to its limit. And as per my opinion, software-defined data center is actually the answer to this. You get software-defined data center when you talk to public cloud provider. So if you're hosting on Azure or Run Node, for example, they're not that popular, but they provide decently sized GPUs at a cheap price. Then you talk about Google Cloud. They offer T4 Tensor Flow. I think it's TensorFlow. TensorFlow processor. It's called T4. So when you try to train a model on Jupyter Notebook, you select Tensor T4, and you're able to actually use it for free. So Google Colab Notebook, when you train the model. So yeah, they are providing that. Grok has some facilities which they provide. Then AWS, they also provide a little bit of flexibility there. Google Cloud also does that. So, but at the same time, if you don't want your data to go out, let's say you're a healthcare or a government body, or I don't know, anybody who's just paranoid about their data, which I am, so I'm like you. But so when we talk about this, I'd rather have my own software-defined data center infrastructure built, which can support my AI workloads, and I will start doing the work there rather than hosting it on Azure, AWS, Google Cloud and whatnot, or even giving my files to ChatGPT, for example, or Claude, or to Gemini, or to Bing, which basically is OpenAI. So that kills the integrity of your data, and you don't know, because nobody reads the privacy policies. But if you're willingly uploading your company confidential document to ChatGPT and asking it to summarize, that's not your document anymore. It still technically is, but actually somebody else has access to it now. So it will be used not for any malicious purpose, but for model training. And it can create some sort of crazy effect. And if you want to know more about AI security, we've got a whole playlist and a whole podcast and a ton of other things. So check out the videos. The link would be somewhere on the screen. If not, go to first hit subscribe. It helps. So if you're building a low-cost software-defined data center to host your AI workloads, I say give it a go. If you need help, drop me an email. My email is in the description. Have a look at it. If you need help, we can help. But it's a good practice to get started there. Now, the key consideration when you're building the hardware and whatnot is to look at converged or hyper-converged. Again, coming back to the subject which we discussed a few minutes ago, maybe 10-15 minutes ago. But the CI or HCI. So again, you need to look at what workloads you're going to run. So if you're running inference, then CI is okay. But if you're running training, if you're training models and whatnot, you need to look at HCI, because scale up, scale down, that kind of thing, right? It again depends on what kind of requirements you have and what kind of access you have to the licenses, to the software, to the hardware. And yeah, by all means, you should go for it. But by leveraging the right tools, whether it's open source or proprietary, and following the best practices, including automation and performance monitoring, you can build an effective, powerful AI solution on top of a software-defined data center that is again yours, and it can scale depending on the needs, and it delivers cutting-edge results as well. Ready to start building your AI empire on your own software-defined data center? Well, it's more than attainable, right? So it can be done. And it's not as difficult as you think. Well, that'd be all from my side. Don't forget to like, subscribe, and share. And I'll see you in the next video.